Welcome back to the GCSE Maths Pro YouTube channel. Today we're going to be looking at the final video on surds. This is rationalising denominators, but now with two terms in the denominator. Again, make sure to check out all the other videos that we have on the surds topic before starting today's video so that you can understand this next part. So rationalising denominators with two terms is basically referring to the fact that we have not just a single surd in the denominator anymore, we have two different numbers. So they could both be surds, or one will be a surd and one will just be a normal ordinary number. The way that we're going to rationalise the denominators with two terms is different to how we were doing it previously when it was just a single surd. We're going to refer back to the video when we did expanding double brackets, and specifically when we looked at difference of two squares. A lot of times students tend to forget what we're referring to when we say the difference of two squares. And actually it's within algebra, specifically within quadratics. So you might have seen it, and I'm just going to give a random example in this format. Let's say x plus 4 and then the other bracket is x minus 4. What we're saying is we've got two brackets, they're basically identical except one's a plus and one's a minus, because if we were to then expand this, obviously we've got x times x, which is x squared, minus 4x plus 4x minus 16. Now if you actually then go and simplify that, you can see that the middle two terms would cancel each other out. You've got minus 4x plus 4x, well that's just 0, isn't it? So we're left with x squared minus 16. Now you can see what we mean by the difference of two squares. Well, x squared is a square number and 16 is a square number. Obviously we've done 4 times 4. And then the difference just means subtract, doesn't it? Like literally, what is the difference between two numbers? You would subtract them. So this is the difference of two squares. The reason why this is now related or relevant for rationalising denominators where you've got two terms is because obviously we are trying to cancel out the surds in the denominators. As I explained in the first video on rationalising denominators, we cannot have surds as the divisor. We can't divide by surds because, let's say in this example, if you looked up square root of 7 on your calculator, yes, it will give you probably 10 digits, but that's not technically all of them. The decimal will go on forever. How are you supposed to divide by an infinite number? That's why we can't have surds in the denominators. Okay, surds are irrational, so we need to rationalise it again. In this case, we have to use difference of two squares in order to cancel out the surds. So how do we do that? Let me just copy our question here. So we've got rationalise the denominator of 1 over root 7 plus 2. So we're going to multiply, similar to the other examples that we had in the other video, we are going to multiply the top and the bottom by the same thing. However, we're going to use this concept of the fact that we have one bracket that's plus and one that's minus. What you're going to do is multiply by the same denominator, except you need to change the symbol. So in this case we've already got plus, so we're going to multiply by root 7 minus 2. And obviously fractions you have to do the same to the top and the bottom, so root 7 minus 2 at the top as well. Now therefore we end up with this double bracket situation at the bottom, don't we? I'm going to write it out fully in the double brackets just so that when I go to expand it I don't make any errors. Now, the numerator sometimes might be a double bracket, sometimes it's single brackets. In this case, I'm not even going to bother writing it as single brackets because we're just multiplying it by 1. So it is just itself, isn't it? It's root 7 minus 2 at the top. Okay, we're going to expand the denominator now, and you'll end up seeing how we end up cancelling out all of the surds using the difference of two squares concept. So the numerator is still the same, there's nothing to simplify there, so I'm going to leave it as it is. And when I expand, so expand it how you normally expand double brackets, you might use the grid method. I just prefer to draw the lines like this. So root 7 times root 7 is obviously root 49. You might be happy to just write that as 7, but I'm just going to write it fully. Then we've got root 7 multiplied by minus 2. So again, be really careful if there's positives, negatives, and so on. We have to make sure that that is correct as well. In that case, it's minus 2 root 7. Now, because we're multiplying together the same brackets, the only difference is the plus and the minus. We're basically doing the same multiplication again, aren't we? Just the other way around. Now it's 2 times root 7, and they're both positive. So plus 2 root 7. So you can kind of see it's the same as what happened here with the minus 4x plus 4x. We've got the same thing, but one's a plus, one's a minus. And finally, we've got plus 2 times minus 2. Okay, so that's going to be minus 4. If I go through and simplify the denominator, so I'll just copy the numerator for now, root 7 minus 2. First of all, root 49, well obviously 49 is a square number because we multiplied 7 by 7, so I can square root it and get just 7. Then if you look in the middle, we've got the exact same thing. We've got 2 root 7 and 2 root 7, but one's plus, one's minus. That's just going to make 0, isn't it? Because again, we can only add or subtract surds that are the same. And they're both root 7 and the same quantity. So minus 2 root 7 plus 2 root 7 is 0, so just cancel those out. And then at the end, we just have minus 4. So can you see how the surd initially was cancelled because we multiplied it by itself? Then we were left over with some surds in the middle, and because we chose to do plus and minus in our 2 brackets, they also just cancelled each other out to make 0. Obviously this last one was just 4 anyway, so that's fine. So I'm just going to go through and subtract the denominator. So I've got root 7 divided by 2, and then 7 minus 4 is 3. Now there's nothing more to simplify there, that is just your final answer. Now we have rationalised this denominator because 3 is a rational number. We can divide by 3. So you can see how difference of 2 squares is the concept we're going to be using. Okay, same question again, the only difference now is that we have 2 surds in the denominator, but we're going to be using the same concept of difference of 2 squares. So let me just copy the question over here to start with. We have rationalised the denominator of 2 over root 15 minus root 5. We're going to multiply by the denominator, but remember we have to change the symbol. In this case we're starting with a minus, we must therefore multiply by a plus. So root 15 plus root 5, multiply the top and the bottom of the fraction by the same thing. You might be happy to just expand this out, but I'm just going to write it out fully. Effectively we've got the single bracket at the top that we need to expand, so 2 multiplied by root 15 plus root 5, and at the bottom obviously we're going to end up with our double bracket situation. Okay, just double check, one's plus, one's minus. Now we can go ahead and expand. So obviously the top's quite easy to expand. 2 times root 15 is just 2 root 15. Again, be really careful as to what is a surd and what is just a whole number, don't get them mixed up. 2 times root 5 is obviously just then 2 root 5, and the denominator we have root 15 times root 15, which is root 225, root 15 times root 5, and they're both positive, so plus root 75. Now we know that the middle bit will also be the same except the opposite symbol, so we've got minus root 5 times root 15. That's going to be minus root 75. And finally, minus root 5 times root 5, so minus root 25. Okay, now we're going to simplify it, so I'm going to leave the numerator as it is. So far there's nothing I can do to simplify that. Denominator we have root 225. You might have skipped that step and just written it immediately as 15 because we know that we did 15 times 15 to get 225, so the square root of that is just 15. The middle should cancel out, so you've got plus root 75 minus root 75. They are the same thing, but one is plus, one is minus, so that is 0. And finally, minus root 25. Well, the square root of 25 is 5, so minus 5. We don't have any surds left. So I'm just going to simplify the denominator. That becomes 10. So we have rationalised the denominator. However, they do tend to want you to leave your answer in the simplest form you can. So we also need to be comfortable with simplifying this type of fraction where we've got some, 2 terms in the numerator now and a term in the denominator. So what we're looking for is a common factor between 2 here, the 2 here, and the 10. Okay, the surds, we can't simplify any further. We can't add them together because they're not the same, root 15 and root 5. We can't add those. But also root 15 doesn't simplify, it doesn't get any smaller in itself, and nor does root 5. So they have to stay separate. But the 2's are kind of like the coefficients, aren't they? If you imagine like 2x and 2y and so on. So we're looking at the whole numbers, 2, 2 and 10. What's our highest common factor? Well, obviously that's going to be 2, isn't it? So I'm going to divide all of these by 2. Obviously not within the surds, just the numbers on the outside. So if I divide that by 2, I'm technically left with 1, but we don't really need to write the 1. Same here. And divide the denominator by 2, which leaves 5. So let me write that out properly. I'm not going to write 1 root 15 because you wouldn't write 1x. It's just implied, isn't it? So root 15 plus root 5 divided by 5. That is the most simplified we can get. So that is your final answer. Okay, if you feel like you're happy with the concept of multiplying by the same denominator but just changing the symbol, go ahead and try this one, pause the video, and then come back when you want to check your answer. So now it's just quite repetitive really. The only thing here is you can see that the numerator also has 2 terms. So we're going to end up with double brackets at the top and at the bottom of the fraction. It's just a longer process. It's all stuff that we've practiced before. I'm going to copy out the question over here. Try and give myself a bit more space. We're going to multiply by the denominator, but I need to change the symbol. So it's already a plus, I need to make it a minus. We're going to multiply by 2 root 2 minus 1 on the top and the bottom of the fraction. Now I'm going to write it out in brackets just so I can expand it more easily. So I've got root 2 plus 6 times 2 root 2 minus 1. And at the bottom, 2 root 2 plus 1, 2 root 2 minus 1. Let's expand it. Root 2 times 2 root 2. So I've got 2 at the front, and then that becomes root 4. Root 2 times minus 1, pretty straightforward, is just minus root 2. Okay, now we're coming to the 6. 6 times 2 root 2. Now remember that 6 is not root 6, it's just 6 as a whole number. So we're just changing the number in the front. So we've got 12 root 2. And finally, 6 times minus 1 is just minus 6. Okay, the denominator. Again, you might get quite good at this and you know that the middle bit will be cancelling out, so you might just go, do you know what, I'm just going to square the 2 root 2 and then 1 times 1, and obviously I know it's a minus in between. You might skip ahead and do that, that's absolutely fine, but again, I'm just going to go all the way through it step by step. So 2 root 2 times 2 root 2 is 4 root 4. 2 root 2 times minus 1 is just obviously then going to be minus 2 root 2. And then you've got the opposite version, so 1 times 2 root 2, which is positive, we've got plus 2 root 2, and finally 1 times minus 1 is minus 1. Now to simplify, 2 times the square root of 4, well the square root of 4 is 2, isn't it? So that's 2 times 2. Then we've got minus root 2 plus 12 root 2. Because these are both root 2, we can actually add them together. So this is effectively 1 root 2, isn't it? So minus 1 root 2 plus 12 root 2 is going to be plus 11 root 2. And then we have minus 6 on the end still. The denominator, 4 times root 4. So the square root of 4 is 2, so we've got 4 times 2 there. These two in the middle, the 2 root 2's cancel out because we've got minus 2 root 2 plus 2 root 2. That's just 0. So cancel those out, and then you're left with minus 1. So let's go through and simplify more. We've got 2 times 2 is 4, but then I've got minus 6. So I'm going to put the 11 root 2 first because that's a positive. 4 minus 6 is minus 2. I'm just going to put that there behind. And then we've got 4 times 2 is 8. Minus 1, which is 7. Now in this case you can see there's nothing we can do to simplify it any further. There aren't any common factors between 11, minus 2 and the 7. That is just your final answer. Same again, just keep practicing it, see what you can simplify after you've rationalised it, and play the video again when you're ready to check the answer. Right, so I'm going to write the question over here. So we've got rationalise the denominator of 5 root 12 plus 2 over 2 root 12 minus root 3. So we're going to multiply by the denominator, but we are changing the symbol. In this case, we need to make it a plus. So 2 root 12 plus root 3. I'm going to write the double brackets so I can make sure to expand it properly, not make any mistakes. Okay, so 2 root 12 minus root 3, and then 2 root 12 plus root 3. Alright, so 5 root 12 times 2 root 12 is 10 root 144. Then we've got 5 root 12 times root 3, which is 5 root 36. Next we have 2 times 2 root 12, which is 4 root 12. And finally, hopefully it will fit, we've got 2 times root 3, which is just 2 root 3. In the denominator, we have 2 root 12 times 2 root 12, which is 4 root 144. We have 2 root 12 times root 3, which is 2 root 36. We have minus root 3 times 2 root 12, so the same thing, but now minus 2 root 36. And finally, we have minus root 3 times root 3, which is minus root 9. So let's go through and simplify. 10 times the square root of 144 is 10 times 12. We can square root that directly. Plus 5 times the square root of 36. Now 36 is also a square number, so we've got 5 times 6. Plus 4 root 12. Now root 12 we know we can simplify. So I'm going to simplify that as root 4 root 3. Plus 2 root 3, we can't do much with that so far. In the denominator, we have 4 times the square root of 144, which again is then 4 times 12. Okay, so the two middle numbers, as always, should cancel out, and you can see that they do. We've got plus 2 root 36 minus 2 root 36. That is 0. And finally, we have minus the square root of 9, which is minus 3. 10 times 12 is 120, plus 5 times 6 is 30, plus 4, and then we can square root this 4, can't we? So 4 times 2 root 3, plus 2 root 3. over 4 times 12 is 48, minus 3 is 45. I'm just going to put this together so we can save some space. 4 times 2 is going to be 8, so 8 root 3. And finally, we've got 120 plus 30, they're both whole numbers, so we can add them to 150. We now can also add these two surds because they're both root 3. So if you look at it, we've got 8 root 3 plus 2 root 3. We can add those. 8 plus 2 is 10 root 3. The denominator is still 45. So we've rationalised the denominator, but is there a common factor between all those whole numbers? So the 150, the 10 and the 45. Well, yeah, we could divide everything by 5, couldn't we? If we divide 150 by 5, we get 30. If we divide 10 by 5, we get 2. And if we divide 45 by 5, we get 9. Let's rewrite that. We've got 30 plus 2 root 3 over 9. And we can't simplify that any further because there isn't a common factor between 30, 2 and 9. That's your final answer. Okay, our last two questions are just written in a slightly different way, just so that you can see how it might present itself in an exam. So while all the other questions said rationalise the denominator of, pretty straightforward, it tells you exactly what to do. In this case, they have worded it differently and it doesn't really mention rationalising. You would just have to put 2 and 2 together and think, right, well, this is surds. I can see that the denominator has a surd in it, and I can also see that the format that they want me to write it in has a denominator where there aren't any surds. So what am I left to do? Pretty much just rationalise. So the question says, show that root 45 divided by 3 root 5 minus 3 can be written in the form a plus root 5 over b, where a and b are integers. Again, integer just means whole numbers. So that's how I know that this denominator doesn't have a surd in it, because surds are not whole numbers. So just go through and rationalise it as we've done in the previous questions. So I'm going to put it here to try and get as much space as possible. Root 45 over 3 root 5 minus 3. So we know by now we're going to multiply by the denominator, but we need to change the symbol. So that is going to be 3 root 5 plus 3. And on the bottom as well. Now, I'm going to write this a little bit shorter so that you can see how I might actually skip a few steps. If you're more comfortable just writing out all of the steps, definitely do that. We don't want to make any mistakes. There are certain things, once you know what's going to happen, especially with the denominator, I can kind of miss the middle bit. So I'm going to multiply these together. Root 45 times 3 root 5. So we've got 3 root 225. And then root 45 times 3, which is just 3 root 45. That's the numerator. The denominator, I know, this is where I'm going to skip some steps, I know that the middle bit's going to cancel out, so I know it's basically just 3 root 5 times 3 root 5, which is 9 root 25. And I know it's going to be minus, because it's then minus 3 times 3, which is minus 9. Okay, so I've made that skip. If you want to write out all the brackets and expand it properly, just to make sure you've got as much accuracy as possible, definitely do that. So now I'm going to simplify it. Well, 225 is actually the square of 15. So if I square root it, I can just write 3 times 15 plus 3 and then 45 I'm going to try and simplify. So I know that would be 9 and 5 over 9 times the square root of 25, which is 9 times 5, and minus 9 still. So 3 times 15 is 45 plus the square root of 9 is 3. So 3 times 3 is 9. This is where it gets a bit tricky because you've got 9 and then you've square rooted it to get 3, but then you times it by 3 again to get 9 again, and it can get really messy, so just be really, really careful. So we've got 45 plus 9 root 5 at the top. The bottom, 9 times 5 is 45, but then I'm minusing another 9, okay, so that's 36. So I've kind of gone through and I've skipped a few steps, but this is what you should get. Now the final thing. Yes, we've rationalised the denominator. As you can see in the question, it gives you a bit of a hint as to what you should be aiming for. Now you can see we've got a plus root 5. That's 1 root 5, isn't it? We don't have 1 root 5 right now, we have 9 root 5, okay? So that hints to us that there's a bit more simplifying we could do. Not in terms of the surds, just in terms of the fractions. That hint is the fact that if I've got 9 right now, there's meant to be 1, I can probably divide everything by 9, but just double check, is 9 a common factor in terms of 45, 36 and 9? Well yeah, they're all numbers in the 9 times tables. So I'm going to divide everything by 9. That gives me 5. Obviously that would give me 1, but I don't need to necessarily write the 1. And this would give me 4. So my answer is 5 plus root 5. I'm not going to write 1 root 5 because that's unnecessary. Over 4. Now you can see A is the 5 and B is the 4. They're both whole numbers. We've got the format that they want, so we're pretty much guaranteed that we've got the right answer. Okay, this is our final question on this topic. As you can see, it's a bit trickier because there's just a bit more going on in the numerator, but we're still going to do exactly the same process. Again, it doesn't say to rationalize the denominator. However, first of all, surds, there's not really a whole lot you can do. What else are we going to do really apart from rationalize a denominator if we have a fraction with surds in it, right? But it says, show that this can be written in the form of a root 11 plus b. Again, where a and b are integers. You can see in this case, yeah, we're going to rationalize the denominator, but ideally the whole thing is going to cancel out and there won't even be a fraction at all. So that gives you a bit of a hint. So pause the video, try this one out yourself, and then come back and check your answer. To start with this one, before I rationalize it, I'm actually going to expand the numerator. So we have 2 root 11 times 1, pretty straightforward. That's obviously then just 2 root 11. 2 root 11 times root 11 is going to be 2 root 121. 5 times 1, well that's just plus 5. And 5 times root 11 is 5 root 11. Okay, over 7 minus root 11. Okay, I'm going to simplify this just before I move on to rationalizing. So the first thing I'm actually going to simplify is this 2 times root 121. Now we did 11 times 11. Well, 121 is a square number, isn't it? So that ends up being 2 times 11, which is just 22, isn't it? So I've got 22 plus 5, so that's 27. And then you can see the other two parts that are left over. We've got 2 root 11 plus 5 root 11. They're both root 11. They're both the same surd, so we can add them. So that's 7 root 11. Okay, so you can see that's simplified it quite a lot, now that we're obviously going to then rationalize the denominator and have to expand brackets again. So now I'm going to multiply by the denominator. Again, change the symbol, so make it a plus in this context. 7 plus root 11. Effectively, it's double brackets, isn't it? So we've got 27 times 7. Quite big numbers, you might want a calculator for this one. That's 189. Plus 27 times root 11. Well, that's just 27 root 11. Plus 7 times 7 root 11. So 49 root 11. And finally, 7 root 11 times root 11 is 7 root 121. Okay, the denominator, again, we kind of know that we're just going to need to do 7 times 7, which is 49, and then minus root 11 times root 11. It's just minus 11, isn't it? It cancels out the square roots. Let's simplify all of this. I'm going to start with these middle two here because 189 I'm going to hold for a second. 27 root 11 plus 49 root 11. They're both root 11, so we can add them together. And we can't simplify the root 11 any further, so that ends up being 76 root 11. And then you can see the last bit, we've got this 121 again. We square root that, we get 11. So 7 times 11 is 77. So we've got 77 plus 189, which is 266. Over 49 minus 11 is 38. But again, you can see we've still got a fraction, and our answer that they've given isn't even in the form of a fraction. It's implying that this should fully simplify. Now, I know we don't really recognise the factors of these numbers, but I'm going to assume everything divides by 38. Let's just assume you do have a calculator. So 76 divided by 38 is 2, and 266 divided by 38 is 7. And obviously that one becomes 1, but you know, if you divide by 1, it doesn't really make any difference, does it? So I'm not obviously going to leave 1 as a denominator. So my answer is 2 root 11 plus 7. So you've got A as the 2 and B as the 7. It completely simplifies. Sometimes this might happen. You might not end up with any fraction at all. So that is everything you need to know about surds. We've been through all of the different topics within surds, rationalizing, surd rules, simplifying everything. Hopefully you found this helpful. Leave down below any questions you might have. Don't forget to subscribe and have a look at all the other playlists we have too.